So here are a few examples for some basic integration. So we went over the power rule. It's right here. That gives your basic formula and one of your only formulas for integration. Add 1 to the power, divide by that, plus c. I haven't pointed this out, but notice it says this is good for n is not equal to -1. In other words, you can't do this. This comes in later. This would become a natural log, but you can do it with, you can integrate with any power except -1. So we'll get to that. There are other rules here too that are based off differentiation. The integral of a constant is a constant times x. This says you can factor out a constant, and this says you can integrate across the sum or difference. And those are just based off your differentiation rules. And we're going to go over those right now. Before we do that, though, this is really important. These are the only rules. A lot of people, when they start with integration, they tend to try to make up their own rules, and you'll see that as we go. You can't. So the hard part of it about integration is just fitting it to these very, very few rules that we have. So the first example I'm going to show you is the integral of 5 dx. So this is just, remember, the dx is just, we're integrating with respect to x. So we have to figure out what the integral of 5 is. Well, from derivatives, we know that the only derivative that will get you 5 is the derivative of 5x. So this equals 5x plus c. It's also this rule. It says the integral of any constant is just a constant times x plus c. So that is question 1. Question 2 says, what's the integral of 6x cubed dx? We're going to follow this rule. The rule says 6 is a constant, so you can think of this as the integral of 6 times x cubed. And the integral of x cubed is, you follow the power rule. You add 1 and then multiply the reciprocal. But now we have a 6 out here, so it's 6 times 1/4 x to the 4th, which is 3 halves x to the 4th plus c. I'm going to redo it here because you don't have to physically factor out the 6. You can just think of it like this. We have this 6. The integral of x cubed is x to the 4th times 1/4. So that's the answer. Reducing, that's 3 over 2 x to the 4th, and then add your constant of integration. You're done. Real quickly, to check an integral, just take the derivative of your answer, and you should get the integrand. So the derivative of 3 halves x to the 4th would be 3 halves times 4x to the 3rd plus the derivative of c is 0. So this would just be the 2 and the 4 cancel. You get 3 times 2, 6x cubed, which is what we started with. So you can always do that to check. So the next two problems, we're going to use this rule that says if you have a plus or minus between terms, it doesn't matter. Just integrate everything separately. So this would just be the integral of 18x to the 5th minus the integral of 5, and both with respect to x. That's all that dx means. So the integral of 18x to the 5th is add 1 to the exponent and then multiply by 1/6. This one, the integral of constant, is just the constant times x. Reduce. That's it. If you take the derivative of this, you can see very, very quickly that it's 18x to the 5th minus 5. Oops, I'm sorry. I accidentally wrote 6 there. I meant plus c. And again, you can see that derivative of this is 18x to the fifth minus 5 plus 0. So one more example. These should be pretty easy. Integration is easy. It's just sometimes it's hard to get it into an easy form. I'll do this one right below. You don't have to rewrite everything. We have a minus, a plus, and a minus, so we can integrate everything without worrying about anything. Just integrate everything separately. The integral of 9x to the fourth is x to the fifth, always do the exponent first, times 1 over 5. Next, 8x cubed. Add 1, multiply by 1/4. Next is 9 has x squared, so plus. Add 1, multiply by 1/2, so we have 9 over 4 now. And then finally, the integral of 4 is 4x plus c. You can't simplify this like we did with differentiation, but for now, we'll just leave it. If you take the derivative of the answer, it should be this. And the last one I want to do today, and we'll get a little bit more complicated tomorrow, but the last one, it's pretty important because it's not a sum or a difference. This one is a product. So we can't do this one the way it's written out. We will be able to do it, but we cannot do this one the way it's written because there will never be any rule for integrating a product, or not a straight rule anyhow. It's not like differentiation where we could use a product rule and be done with it. So we need to change this into a sum or a difference. And so the first step is just multiply it out. So if you FOIL this, you will get 2x squared minus 4x plus 5x, so plus x minus 10. Now integrate, just like the one before. So this would become, move it up a bit. This will become, after integration, add 1 to the exponent, multiply by 1/3. Next, add 1 to the exponent, 2, multiply by 1/2. And 10 is a constant, so minus 10 times x plus c. That's it for today. Make sure you practice them.